It's 12 o'clock and it's about to start. First of all, I want everyone on the call to know that I have started the recording, so this meeting is recorded. Today we were supposed to have a SQL Friday with Olivier van Steenland, who was going to talk about database projects and Azure DevOps and team collaboration. But Olivier, unfortunately, is ill. He caught COVID. So he contacted me earlier this week and told me he had a positive test and didn't want to cancel on a late notice. So we decided that we will postpone Olivier's presentation. So today you're going to be stuck with me instead. And I have a presentation about SQL Server 2022 and the things that I think stand out in SQL 2022. It's not a full feature list because you can't really do that in 1 hour. And I wanted to do some demos. I did want to do a SQL managed instance link demo to set up basically a bidirectional replication between your on-premise SQL Server and the managed instance. But I kind of forgot that I had some preview functionality on the managed instance, and I figured out I would use that. But since it was some preview features, it was decommissioned when I was setting up the demo. And if you have ever created a managed instance in Azure, you know that it takes quite a few hours to create the managed instance. So I just didn't have time to do it, unfortunately. So that's one demo I wanted to do, but that I won't be able to do today. What will I be able to do though? Is someone having a microphone on? I'll mute you for you. There we go. So before we get started with the actual presentation, if you have any questions, I'm going to monitor the chat to the best of my ability during the talk. I'll look into the chat between sections, basically. So if you have any questions, please type them in the chat. SQL Server 2022, it was released to manufacturing, which really isn't how it works anymore, but it's still called RTM. It was released to manufacturing in November during PASS Summit, I think it was. And it had been in public preview for quite some time before that. So it was a long-awaited version of SQL Server. We knew that it would have more intelligent query processing features, but I was a bit surprised that we also had so many new T-SQL features. So I will go through them, and the demo will be basically focused on the T-SQL stuff. So a few words about me. I'm Magnus. I'm the organizer of SQL Friday. I am a SQL Server consultant in Transmocopter SQL AB, which is my own company. You have my contact details on the slide, which I hope you can see. The demo code is, I think, already uploaded to my GitHub account. If it's not there, it's going to be under presentations and then a subfolder called SQL Server 2022. And in the presentations repository, you can find all my presentations that I do. So if you're interested in anything else or demo code from anything else I've done, it's all there. I can't guarantee that all the demo scripts actually work because they may be checked in while I did some changes during a presentation. So normally the only time I really know the demo scripts work is just before I make presentation. So take it for what it is. Some shameless plugs. This is actually the PowerPoint from a previous conference I was at. So I made a plug about SQL Friday. You guys are already here in SQL Friday, so I don't need to tell you about it. On youtube.com/c/transmocopter, you find some recordings of SQL Friday sessions, and you also find some recordings that I've done. So few videos about temporal tables, a few videos about how you can use a tally table to speed things up or solve complex problems with tally tables, and some performance comparison between that and other ways to do the same thing. We will talk a little bit about analytics improvements. I don't work with analytics, so I can't really say much about them. I will just mention the things that other people are spoke about. So some Synapse link and stuff like that. I will talk about intelligent query processing, and there are quite a few additions to that headline, so to say, in SQL 2022. Many cool things. I guess someone will announce the death of the DBA because query tuning and performance tuning is done automatically again. I think there will still be DBAs in the future, but they will do maybe some other things, because some of the intelligent query processing features that we get are they use query store and they kind of adjust things over time, which is kind of cool if it works. And I know Microsoft put in a lot of work, so some of the things work really, really well. There will still be edge cases where things don't really work the way you expect them or want them to do. But overall, we get a performance increase with just installing SQL Server 2022. You maybe remember SQL 2016 had the kind of tagline or subtitle, "It just runs faster." And I think we can say the same thing about SQL 2022. I heard a DBA who he has tons of databases, like thousands, and in their test environment, they just ran a production workload in the test environment to get a baseline and then upgraded to SQL Server 2022, and this was CTP1, and they saw a 20% performance increase by. They didn't do anything else than just upgrading to 2022. They didn't enable any features or disable or tune anything. So if you run your workload in a cloud environment, that's money directly back into you, because you basically pay for what you use, and if you use less resources, you'll pay less. So it's pretty cool. I will talk about the managed instance link. I hoped to do a demo. There won't be a demo of managed instance link, so I'll just mention it a little bit. I don't have any nice pictures in my slides about it because I meant to do a demo. Hopefully we can get back to that at some other occasion. And then we will end with a demo about the T-SQL language additions. Timing wise, I have really no idea if this is going to be 45 minutes or 75. I'll try to not hold you here too long. But even if I practice my talks and they end up 40 minutes, they still end up in 70 minutes when I do them live. But we'll see. Timing is not my best, basically. For analytical workloads, anyway, in SQL 2022, we have the Azure Synapse link, which is how should I? You don't need to import stuff into Synapse. Basically, you can use a SQL database or a SQL table in your Synapse workspace. So I think that's for many people this has been long awaited, and they really like it. I don't really work with Synapse, so I can't tell you if it works well or not. But, it's a feature that people waited for. Now it's there. So talk to someone like Kevin Chant or someone. He'll tell you if it works well or not. We have backup to URL, which we have had for a long time. We can back up to a storage account in Azure with backup to URL, but now we can also back up with backup to URL directly to an S3 bucket, which is pretty good, I would say, because it makes the multi-cloud reality a bit easier, among other things. We have poly-based support for T-SQL queries against S3 buckets, which is also cool. So we can take just an S3 bucket and add it as an external table and query it with polybase, just as if it would be a local table. So less need to do the ETL. If you have the raw data in an S3 bucket, you don't need to import it to your SQL to query it. You can just query the S3 immediately. With that said, it's obviously going to be a lot faster to query a data source if that data source is an actual table in SQL Server. So many of these things that we can do, it doesn't mean that we always should do them. There's still going to be a need for ETL and ELT workloads, but just the ability to map an S3 bucket as an external table and query it is kind of nice, at least for one-offs, or when you can use it to import data much easier because you can do it from T-SQL directly from the database. So I think that's pretty cool. These are all things I haven't tested extensively, and some of the things I haven't tested at all, but I just wanted to mention that these are cool things in there if you work mainly in the analytical side of things. I work with SQL Server mostly for OLTP workloads, so transactional systems, some reporting, but mostly transaction systems. And for me, the intelligent query processing pieces that are built into SQL 2022 are really good stuff. Good news for me, basically. The first thing is the ability to have a query store on its own on an readable secondary replica in an availability group. So if you have an availability group with a readable secondary where you do your backups, for example, but you also put your reporting workload onto that secondary, or you could have a super fancy system where you have you have two connection strings, one for writing and one for reading. The problem we have had with readable secondaries in terms of performance is that we're kind of blind to what happened when we ran a report yesterday, because the query store would record whatever happened on the primary. If we ran a query on the secondary, there was no query store. So in preview as of now, I guess it will be GA in not too long. We can have an own query store for the readable secondary, so that you get a query store for your reporting workload. To be able to do it, you need to enable a trace flag. I'll get back to that in the T-SQL demo. Which trace flag it is, and you need to enable, you basically do alter database name for secondary, and then you will enable the query store for the read-only replica, or for the replicas, because at least in the preview, it's either on all readable secondaries or none of them. You can't say that you only want the query store on one of the readable secondaries. So, next cool thing is query store hints, which we get in query store. You are able to add query hints to a query. It's super useful if you have a third-party system. You're not allowed to change the source code. Maybe you don't even have access to the stored procedures, and 100% you will break the SLA agreement if you change any of the stored procedures on your own. So you have a provider of a software, then you can use Query Store to add query hints to queries in Query Store. You don't change the source code at all. You just change the behavior. Is it possible to synchronize system databases in availability group? Yes, it's a question in the chat from Henrik. Yes, it's a topic on its own that I don't really have in my in this presentation, but it's also one of the things you're able to do in SQL 22 to create a contained availability group where the system databases becomes part of the availability group. And the way it works is basically that system databases are copied to user data. They will become, you'll get a copy of the system databases as user databases, so that you can, in an availability group, create logins, for example, which are only available in the availability group. Gabor has the question, and SSIS DB. I don't know really. I'll get back to you about that, Gabor. I'm not sure. Availability groups for SSIS DB. Not sure. Anyway, so query store hints. So let's say you have a parameterized query. If you see it in Query Store, it's going to be parameterized. And you have a skew in your data. So sometimes the queries run fast, sometimes they don't, or you have basically a parameter sniffing issue. One of the things you can do is to add a query hint like optimize for unknown or optimize for a specific value. So I think that's pretty cool to be able to do that without touching the code. What more? Things that use Query Store. Basically all the things you see on this slide, they will use Query Store one way or the other. So we had in SQL 2017, I think it came, the memory grant feedback, where if a query got a too large or too small memory grant, SQL Server would detect that, mark the execution plan. The next time it runs, it's going to adjust the memory grant either up or down, and do that until it found stability. But finding stability wasn't super scientific. I think it's like, let's try it 3 times and then kind of lock it to a certain memory grant. But what if your queries sometimes need a big memory grant and sometimes need a small memory grant? If you set up a hash match inner join, or the execution plan contains a hash match, then you would need a memory grant which is as big as it needs to be based on the kind of driver table to that hash match, because hash match is basically you have one source of data coming into the hash match that would build up a hash table, and that hash table needs to be as big as the number of values coming into it. And if you don't really know how many values are going to come into it based on parameter sniffing or something else, sometimes a predicate will return 3 rows and sometimes 3 million rows. And if that's your normal workload, then the old memory grant feedback didn't help much, because it could lock the memory grant to a tiny amount, and you would still have the spill to temp DB because the value was kind of locked. With the improvements to memory grant feedback, SQL Server is looking back not only at the previous execution, but actually at the time series of executions, and try to kind of find out what will be a memory grant that fits the workload. not just the previous execution of the query. So I think that's it's pretty good, and you get the feedback information is stored in query store, not just in the execution plan. Because when it was stored in the execution plan previously, you just knew the previous execution, what memory grant it had, and if it was too big or small. So now you'll get that information persisted for every execution of the query, which is why it actually works to create a nice works for most memory grant. Another thing also using query store is parameter sensitive plan optimization. What does that mean? Well, that means if you have a skew in your data, my favorite example is you have one customer with 1 million orders and 1 million customers with 1 order each. It's an extreme skew. Then if you send in a query to the orders table with a predicate on customer ID, and then you join it to something else, you would want different query plans for the one customer has 1 order based compared to one customer has 1 million orders. And parameter sensitive plan optimization is basically going to create multiple plans for the same query and keep them and looking at the parameter values as they come in and see which plan fits with this parameter. So it's still parameter sniffing, and parameter sniffing is mostly good because parameter sniffing means you can reuse a plan, but now you get different plans for different types of parameters. It's not gonna just fix all your problems on the first day, because most of these features, they require that something has happened over time. It requires more data in query store to be able to use that information to create this second execution plan. If you look in some articles on the internet, you will probably see some fixed values, like if a parameter, if one predicate for one parameter produces a data set of 100 rows, then that's going to be one threshold, and the next is going to be something like 1 million rows. And these are probably fixed somehow in code, but they're not documented, meaning they will probably change with the CU or something. So don't really trust those articles. Things will change, and they will change based on how we use and the feedback we give to Microsoft on how well this feature works. DOP feedback. DOP is degree of parallelism. When does a query run in parallel? Well, it runs in parallel if the cost for the query is larger than the cost threshold for parallelism. And cost threshold for parallelism is an instance-wide setting. I think it's a database scoped configuration nowadays too, but it doesn't matter where the setting is. There is a threshold for parallelism, and it's based on cost. And the cost, I've heard that the cost is equivalent to the number of seconds it took to run a query on a Pentium computer somewhere in Microsoft Labs, which they used to test parallelism when they implemented it for SQL Server 7. I don't know if it's true, but the cost threshold for parallelism, it's built on a number. When SQL Server creates an execution plan, it tries to figure out what's the cost of this execution plan, what's the cost of each operator. And that's a guess. And that guess could be completely wrong. If you have a bad cardinality estimation, well, then the cost is going to be, the real cost is going to be different. And the DOP feedback basically works on if you get unnecessary parallelism, DOP feedback is going to adjust and use maybe fewer threads or fewer workers, or just stop doing parallelism completely. It won't go from 16 threads to just one. It'll take it down a notch, see if it improves things. If it doesn't improve, it'll go back to the previous value. If it does improve a little bit, it'll go down to a even lower and test. And this is also one of the features that will take days, if not weeks, before you will actually see it kick in and do any difference for your workload. Because they don't really want to have a DOP feedback that changes the parallelism every time you run a query. What else? We have cardinality estimation feedback, which is also like we have most of the things that we want. Let's go back. The most important factor for the optimizer to be able to create a good execution plan is the cardinality estimation. If I query a table with a specific predicate and SQL Server thinks this predicate is going to return 100 rows and it returns 1 million rows, then the execution plan is going to be bad. And the cardinality estimation feedback it's also data stored in query store. You'll see estimated number of rows and actual number of rows in your execution plans when you run a query. So that data is persisted. And if there is a huge difference on a specific operator or predicate, the feedback loop is going to kick in and change the execution plan to one that fits the actual number of rows better. So these are like the intelligent query processing features introduced in SQL Server 2022. And like I said, people who tested this just ran a production workload on a test environment upgrading to SQL Server 2022 saw something like 20% increase in performance. Don't hold me accountable to that number though, because your workload can be super different and you may see a 20% decrease in performance, but it's not likely that you will see that. MI-Link, this is, if you want to migrate a big system to Azure, you will either think about rewriting a whole lot of things and use Azure SQL database and so on. But if you have a big system, it has lots of databases and the system has a few years under the hood, I'm pretty sure you will see cross database queries flying all over the place. And then Azure SQL database is not going to be an option because there is no cross database queries allowed in Azure SQL database. Because in Azure SQL database, the entity that you run something against is a database, not a server. So then managed instance will be the way to go, at least as a first step, because it takes time to rewrite code for applications. So when you want to migrate, prior to the managed instance link, you would have downtime, guaranteed, if you wanted to migrate a database to a managed instance. Which is why many took the step to migrate to a VM in Azure instead. But then you still have to maintain the operating system. And one of the ideas with using a cloud environment is to use basically applications as a service, the SQL Server as a service. So that's why managed instance exists in the first place. But prior to MI-Link, you would have to do a backup, send it somewhere, restore it. It took a while. If the backup was super large, you'd have to have Microsoft help you do it, and it would mean downtime, basically. With MI-Link, what you basically do is you create a normal availability group in your on-premise database, or in your Azure VM, if that's where you run your SQL Server, but basically SQL Server for Windows, if that's what you're running. You create an availability group per database, because MI-Link is a per database feature, so you can't have an MI-Link that contains multiple databases. So you create the one database availability group, either on multiple nodes in on-premise or just one node. And then you create a distributed availability group on top of the availability group, where, I mean, one member of the distributed availability group is going to be your local availability group, and the other member is going to be your managed instance. And you do that in SQL Server side, and then you have to use Azure Client or Azure PowerShell or whatever your tool is to configure your Azure environment, and create the managed instance link there, which is basically creating the availability group, but it's called an MI-Link in Azure side of things. And that would start the replication of data. I think so far automatic seeding is our only option. I guess that will probably change sometime. So doing that on a super big database is going to take some time, or a lot of time, to do automatic seeding. If the databases aren't so big, well, the seeding takes as much time as it does, and the factors are network connectivity and stuff like that. How fast is your network between on-premise and your managed instance? But you can do that and leave it, have it do the automatic seeding, and when it's done, you will be able to query your managed instance as a readable secondary. You can test that your applications, at least the read-only workload, that it works, and then you can do a simple failover to Azure when all your applications are in Azure. You have the connection string set up, and then you can do the failover when you want to switch. And during the preview, this replication was one directional, so when you failed over, you couldn't fail back. But when SQL Server 2022 was released in GA, Microsoft also announced that it's now bi-directional, so that you can actually fail back to on-premise, and that makes it also a use case for using Azure as a DR site for your databases. I mean, for me at least, databases are, I mean, that's the most important asset to keep safe. So if your data center blows up, chances are your backups are gone as well. If you then have all your data in Azure as well, in a managed instance, at least you have the data intact. The prereqs for this is, of course, you have to have a SQL instance, either on-premise or in an Azure VM. You need to have an Azure SQL managed instance, and you need to have network connectivity. And that network connectivity cannot be a public endpoint, because the actual replication in the distributed availability group is going to be on mirroring endpoints, so port 5022 or something, and you can't have a public endpoint for that. So it needs to be either point-to-site or site-to-site network connectivity between your VNet in Azure and your SQL Server instance that you have installed. And I'm still disappointed that I can't show you this. And the reason I want to show you is to show that it's actually quite easy to set up. Nowadays, it even works to set it up in Management Studio with a ClickOps operation. Right-click on a database and join it to a or set up the distributed availability group against the managed instance, and it's done in a wizard basically. But that wizard, you can have it produce a SQL script that contains the SQL that you need to run on premise, and also in comments it will have the PowerShell scripts you need to run in Azure PowerShell. Cool stuff. Last section is the T-SQL language editions, and as I said, they are quite a few. Let's see, Andre says, seeding will keep log file growing until it's done, right? Yes, Andre, you're right about that. So if you do automatic seeding, and if you anticipate that it's going to take 4 days, make sure you have 4 days worth of transaction log space on the transaction log disk. I wouldn't want to do automatic seeding on terabyte sized databases, to be honest. But most databases in the world aren't that big. So it's automatic seeding is an approach that works for most, but not for the biggest databases. If you have super large databases, contact Microsoft and get some advice on how to do it best, because they have worked on these scenarios thousands of times. T-SQL language editions. We now have resumable add table constraints and index operations. We have had resumable index operations for quite some time in SQL Server. So what's new is that we now have resumable constraint operations. So if you want to add a primary key, you can have that as a resumable operation. So you can have it online. It can be resumable. You can schedule it to run. If you have a table where you know it's going to take 2 days to create a primary key constraint, you don't really want to have your system down for that long. You don't want to have this, what basically under the hood is a create index operation. You don't want that to happen during your most busy hours in the system. So then you can schedule it to run for a few hours and then pause and then resume in the next kind of service window. So I think that's cool. We can have auto drop on statistics to avoid DDL blocking. What does that mean? Well, it means if you have a statistics object on a column and then you do an alter operation on that column, you drop it or you change it somehow, then that statistics object is going to be invalid. And under certain circumstances, this could cause blocking because that statistics object wouldn't allow itself to be dropped. So it could block your DDL operations. And now you can set auto drop on statistics objects. I don't remember if that's going to be the default or if you have to set it. It's something you can do afterwards when the statistics object exists, at least. We can have named windows. I'll show in a demo, but basically if you have window functions, they have the over clause. So the over clause can be named as a window, which I think is nice because it's quite often if you do a reporting query and you have like 10 different columns in the output with window functions and you have the same over clause for all of them, and then you decide that you want to change the window and just look at the 14 previous days instead of the 13 previous days, and then you'll have to change it in 10 places. And it's not that I'm lazy. Well, I am lazy, but it's not only because I'm lazy. It's also because I'm clumsy. So I'll do 9 and forget the 10. And then if I have a named window, I'll just change it in one place. So it makes for better quality code, basically. We have had some wonky ways to handle null values, especially give me all rows in the order table where product ID is not 3, and you had null values in that table. Well, then they wouldn't be returned either from the predicate not 3 and not from equals 3 either. And therefore we now have the is distinct from and is not distinct from ways to put into a predicate, basically. That's in the demo as well. Date bucket, I'm not going to try to explain it here. I'll try to explain it in code instead when we look at it. Generate series, super cool. I have quite a few demos where I have a CTE that does a cross join against a number of constants and then puts a row number to them. I don't need to use that CTE anymore because generate series will give me a series of integer values, basically. And you can decide when you generate a series what's going to be the start point, the end point, and how big should the steps be between each value. And now my Siri on my phone thinks I'm talking to it. I'm not Siri, sorry. First value and last value are window functions, and you can now instruct them to either respect nulls or ignore nulls, which is different from how it was before. We have some JSON features. I hate JSON myself. I love XML because XML is it's structured, it has a schema and so on, but not everyone loves XML. Some even love JSON, and now we have better ways to manipulate and read JSON in SQL. There has been functions percentile count and percentile disk for a while. I think they came in SQL 2012 even. Anyway, now we have approx percentile count and approx percentile disk, which will give us, well, if they're accurate enough or not is going to be up to you or whoever writes the requirement, but they're going to be close to the exact value of percentile count and percentile disk, and they will be tons faster. So basically what they will do is to sample the data instead of scanning all the data. So faster and not really accurate, but close enough for many. A very small thing, but super important, I think, is the enable ordinal in string split. String split is a function that has been around for a couple of versions. It basically takes a string, splits it, and creates a data set from it. And now we have enable ordinal, which will number the items and it will be correct. You have been able to do it yourself with just using row number function or something with an empty overclause or a fake order by in the overclause. But it hasn't been guaranteed to be correct because what if someone decides to enable parallelism for a string split? Well, then the ordinal wouldn't be correct. And if you need it to be correct for, say you have a financial reporting application and you get a string with comma separated values and you really need them to come in the correct order, then you would have to write your own string split basically prior to SQL Server 2022. But now with enable ordinal to string split, we're guaranteed to get the correct order of the items. So that's cool. Greatest and least. These are two functions that you have been able to do whatever these functions do with case expressions or similar techniques. But it makes life easier to just have based on these numbers, which is the greatest or which is the least number of this series of numbers. Date trunc also takes away some ugly code from our applications. It truncates a date value based on whatever date part you send to it. So you can use date trunc based on year, and then you will get still a valid date, but it will just contain the year and then the first possible month, day, hour, etc., etc. If you truncate on second, you will just cut away the seconds and get the resolution down to minutes, and so on. So basically, cut off some details from a date time 2 or daytime. We have some additions to the trim functions. For example, we can trim off a specific string from the beginning or the end. So not just trim white spaces, but trim off, let's say I have a prefix in strings, 3 letters, then I can use the trim function to get rid of those. And we can also, on the trim function, we have some keywords, leading, trailing, or both. Both is going to be the default, but you can use, instead of using left trim and right trim and combine them, you can use just trim and say that I just want to trim off leading so-and-so from this string. And finally, I think at least we will have some true bitwise operations like left shift, right shift, bit count, get bit, and set bit. Do you want to use that? I mean, is it always a good idea to use bitwise operations on let's say a tiny int? Well, probably not. And performance-wise, definitely not on a large data set. But if you want to store configuration that way, well, it's possible to store configuration with up to 8 bits in a tiny int, and you can use the true bitwise operators to figure out is the 4th bit set or not, and change it to set it or not. Let's switch to Management Studio to look at some T-SQL. I promised to tell you which trace flag you wanted to enable. If you want to have a query store for the readable secondary, it's trace flag 12606. You cannot do DBCC trace on. You have to set it at startup. So basically go into Configuration Manager and enable that trace flag in there. And then you need to do alter database and then the database name, keywords for secondary, and set query store on, and operation mode read write, which is a bit wonky because when you look in the secondary, the operation mode isn't read write. The operation mode is something readable secondary something. I don't remember what it is. If I look in Management Studio, it's not going to display the operation mode on the secondary. It's just going to give me the number 4, but that's 100% just presentation in Management Studio. It's a preview feature. I run the SQL Server we're on right now in Management Studio is running on Linux, or it's actually running a container. So I didn't quite get that feature to work. It works. It does store the query store data in the secondary and so on, but I can't see it in Management Studio. In the GitHub, you have a slightly different code sample. Can you share this one or provide the path in GitHub? I will push these changes to the repository presentations in GitHub. So then you will have exactly this code in GitHub. And if you want to look at how it looks right now, just go into the history of that file and look at different check-ins for it. So it will be there. Let's start looking at what version of SQL Server we're running. We're running SQL Server 2022 RTM. You get the build number and stuff like that. And we see that it's running on Linux Ubuntu. And that doesn't really matter. For anything T-SQL, it's going to be 100% the same in Windows and Linux. So the levels of virtualization. When I started working with SQL Server, the truth was that if you wanted performance, you would have a physical box. You would install physical disks in that box, and then you would install SQL Server and attach or put the databases on those physical disks and so on. Nowadays, I'm running Windows 11. I'm running Docker for Windows or Docker desktop. I have Windows subsystem for Linux, which Docker connects to create the containers. So I run my Management Studio in Windows against a container running a Windows subsystem for Linux in my Windows 11. So a few levels of virtualization, and nowadays you really can't notice the difference in performance based on the levels of virtualization, because it's kind of effective. We're going to use a database called Sandbox. Woo, super good name. I have one table created. I call it instance specs. It has these very interesting this data in it, a CPU count and an instance name or a server name, maybe. So CPU count 32, many CPUs 1. CPU count 4, few CPUs 1. So 10 rows where I have a CPU count and 1 row where I have a null value and a name of an instance. So this is all the data we're going to work on in this demo. First, I want to have a primary key on my table. So I'll create one. And when I create it, I will create it with resumable online on, and the max duration of 30, which I think means 30 minutes. Could be seconds. I think it's minutes. But as you saw, this table has 11 rows, so it's not gonna run for neither 30 seconds or minutes. It's going to be instant. I just wanted to show the syntax of a resumable constraint operation. So let's run it. Now we have a primary key. Imagine that it would have run for 30 minutes and I need to stop it because now we're open for business. I can't have a primary key operation running while customers are trying to use the system. Then I could have done alter index all on DBO instance specs pause. So pause the index operations. And since adding a primary key is an index operation, this would have been paused. And later on, I could have done alter index all and do a resume operation, set the max degree of parallelism, another max duration, wait at low priority. I think if you want to do an online index operation, I think it's a good idea to use wait at low priority. What does it mean? Well, when you create an index or a constraint online, what's really happening is that it's created as a side structure. And then as the very last step, it's going to be connected with the table or attached to the table. And that's a schema-only operation. But to do such schema-only operation, you need to acquire a schema modification lock. Anything that uses that table has set a schema stability lock on the table, and these two are not compatible. So my schema modification lock, the very last step of the index operation, would have to wait for the schema stability locks to be released. So I'm waiting to modify the schema. Anything that uses the table has to finish up first, and that's no problem. But any other schema stability lock coming in will have to wait behind me because I came in before them. So that could create a long queue of operations. If you have long running queries with the stability lock and you're waiting to set the modification lock, well, no one can read the table in the meantime. And then the operation isn't really online after all. So if you set wait at low priority, your modification lock is going to stand here waiting and let all the stability locks pass. And then you set a max duration for the wait at low priority. And you decide also in the wait at low priority clause what's going to happen if I wait for 10 minutes. What will happen after 10 minutes? Who is going to be aborted? Is it going to be me or the blockers? So I think that's the proper way to do an online index operation. And now you can do it with a constraint as well. That's what I wanted to show. Next thing, named windows. If I have a window function like this, I have a window aggregate function, count star over all rows windows. That's not a proper over clause, but I define that in the window clause in the very bottom of the query. So all rows windows, well, that's an open over clause. Okay. And then I have another one, same CPU count window, partition by CPU count, order by select null. It's not ordered actually, but I wanted to have rows between unbounded preceding and unbounded following. So running this, it gives me a result. It's the exact same thing as if I would have copied this up to here over this and copy the empty over clause to up here. So it's just syntax, but it does make your code more readable, especially if you have multiple items in your select list. So I'm going to do undo and get it back to how it was. Very nice, much easier to create readable code, at least my point of view is that, and less mistakes when you have multiple items in your select list with the same window clause or the same over clause. Now you're able to change them in one place, so you don't have the copy paste mistakes or miss one row when you change something in your code. I talked about null handling. In the old days, that's yesterday, old days, before SQL 2022. If I did give me all the rows from instance specs where CPU count isn't 4, I'll get these rows. If I do give me all the rows from instance specs where CPU count is 4, I'll get these 5 rows. The table contains 11 rows. So this is a problem as old as SQL, the 3-part logic. Something can be either equal to, not equal to, or it could be unknown. And null is treated as unknown. So give me everything that's not 4. The SQL language defines that null is unknown, so we don't know if it's 4 or not. So let's not return it when we compare to not 4. So the way we would have to do it before SQL 2022 is give me all the rows from instance specs where CPU count isn't 4 or CPU count is null. It's an or. Or is not optimizing in a fantastic way, to say the least. And the code is ugly. And if the predicate is more complex than this, it's easy to make mistakes. You'd have to use parentheses and stuff like that to be sure that the predicates are evaluated in the correct order, so on. There is an alternative to the OR, which optimizes much better. You would use not exists, select 4, intersect, select CPU count. So CPU count is selecting the CPU count from the current row, and the 4 is a constant, and we look for the intersection of those two, and we have a not exists on that. Intersect treats null as a distinct value and not as an unknown, and therefore this works to return the null value. And it optimizes better than this alternative, but it's still ugly, and it still makes your code very hard to read if you have many predicates. In SQL 2022, we get give me all the rows from instance specs where CPU count is distinct from 4. And it's a way to treat null values as a value and not as an unknown. Date bucket. A date bucket is going to give you a date. And which date? Let me try to explain. I have a base date, which is current timestamp right now. Is going to be the base date if you don't enter a base date to the date bucket function. And I want 3-month buckets. And what this function is going to do is look at current timestamp and give me date. Let's see. Oh, my bad. Sorry, I didn't. This is the value we're looking at. It's not the base date. So the value now, if I put that into 3-month periods, with 1st of January 1900 is the default base date. So my bad. So which is the first date in the 3-month bucket that current timestamps live in? If I give another base date, for example, 1st of November 2022, I will get another first date. So 1st of November 2022 is the first date in our time series. So if I want to divide my time series into 3-month buckets, then, well, the first bucket is going to have 2022-11/01 as the date. The next bucket is going to be 1st of February 2023, and so on and so on. And it's a way to, let's say you have some strange reporting periods, like you report NASDAQ or something. And you have your reporting periods. Now you can define them in date buckets this way and give a base date, which would be kind of when NASDAQ started with these reporting periods. So good for reporting. Play with it. It's not super intuitive how it works, but play a bit with it. If you do a lot of reporting, you would probably love it. Let's speed up because we're behind time, actually. Generate series. It does what it sounds like. Give me a series of integers from 1 to 100. Or in this example, give me a series of integers between 1 and 100 with 3 between each value. So 1, 4, 7, 10, 13, 16, 19, etc. With dates, let's try it. Generate series with 2 dates. No, doesn't work. So we'll have to play with date add to create a date series. So we have the generate series 0 to 1000, and then we add a day to a base date for each row. And this way we can create a calendar dimension somehow. Right. Let's skip these. It's just a combination of using generate series and date bucket. You can look it up on your own if you download the code from GitHub. So we speed up a little bit. Is JSON. The string hi there, is that JSON? Nope, it's not. The string curly brackets hi colon there, is that JSON? Yes, it is. So is JSON validates a string and tells you if it's proper JSON or not. JSON path exists. We can use that to see a certain element which lives in the info element, and under that, do we have an addresses element? I need to declare the actual string first. No, because here we have a person and then address. We don't have info and address. So let's look up person, address, first element of address. Does it have a town element? Still need to define it. Yep, that one exists. So it's a way to search a JSON structure to see, do we have this element in this place? Kind of a way to validate schema of a JSON, but JSON is supposed to be schemaless, and that's why I love XML instead. We can construct JSON with the JSON object and JSON array functions. So I want to have a person, it should have a value, and that value should be this JSON object, etc., etc. And doing this, we can construct a structured JSON result. String split. Normal string split in the old days, we just split the string. If we add parameter value 1 after the separator, we would get the ordinal of each of these values. And we can use a 0, but that's going to be the default behavior. Greatest and least. And finally, I get some use of my instance specs. How many tempDB files should you have? You should have 1 per CPU core divided by 2, but no more than 8. This was at least the old best practice. And with the least function, you would just take CPU count divided by 2 and 8 and return whichever is the least of these two. So that's what the least function does. The greatest does the exact opposite. Give me the larger value. Date trunk. Truncate current timestamp based on year. It will give me 2023, that's the current year, and then whatever is the first of everything following there. So 1st of January, midnight. Let's truncate down to month instead, and then I'll keep second month, which is now. And we could do it down to second or even millisecond. But let's try it with second, and we will get the date, the hour, the minute, the second, but the milliseconds are stripped off. Trim. Trim off the leading ABC from ABC 1 to 3 ABC. trim off the trailing ABC from ABC 1 to 3 ABC, or trim both ABCs, or trim both means trim off both leading and trailing ABCs from the string ABC 1 to 3 ABC. Simple. We have been able to do this with much more complex code. So it just small additions that makes life a bit easier for SQL developers. The very last thing, bitwise operations. From the number 8, is the third bit set or not? Well, let's look at it with getBit. Yep, it is. What's the bit count of the number 7? Meaning how many bits are 1 in the number 7? 3 bits are 1. And set bit number, let's take the number 8 and set the first bit in that byte. That will give us the number 9. We can use left shift and right shift on number. So if we shift the number 8 left, it will be twice as big. What it means is basically take the ones in that byte or in that word or whatever, it depends on the data type, and shift them one step to the left. And that will give us the next new number, and right shift. And this is in the old days when I used to program graphics in Pascal, we'd just do some inline assembly to do shift operations instead of doing multiplications, because back then shift operations were much faster than multiplication. And then we had faster CPUs and smarter CPUs with math processing units, and we didn't need to do it anymore. But there are still use cases for doing shift operations in bitwise shift operations. I can't think of one right now, but they are there. So I think the bitwise operators, most people won't care about them, but the people who try to do bitwise operations in SQL will be able to throw away ugly code and replace it with something that actually explains whatever these operations do. What about is null CPU count, 0, is a question from Alexander Jäger. Let's go back to that, and that will be the last thing we do. Where did I have? So where is null CPU count, 0? I think this is what Alexander means. This is going to produce a correct result, but it won't be able to use an index properly, because it will have to apply the isNull function to the CPU count column for every row to decide if it should return the CPU count or 0. And therefore it's a predicate is said to be sargeable or not. And if it's sargeable, it basically means it can use an index to do a search operation. If it's not sargeable, it will become a scan operation, which will be less efficient. So that's the reason I didn't show this. So now, since we have 11 rows in the table, we're going to get a table scan every time, regardless of what we do. But if we have 11 million rows in the table, we would see different execution plans from, I think, actually from all of these. That was all I had. I'm sorry I kept you a little bit longer than an hour. I did warn you, though. I hope you enjoyed this kind of a teaser into SQL Server 2022. And this season we will have more speakers who will talk about SQL Server 2022, and they will go more into depth with some of the features that I mentioned. So stay tuned.